Much of sub-Saharan Africa suffers from poor soil, poor crops, poor water quality and poor livestock health. All these contribute to poor human health and stunt economic development. There have been very few changes in farming practices over the last 30 years in sub-Saharan Africa, largely because the typical African farmer is trapped in poverty. This is leading to increased food insecurity, water scarcity, and environmental degradation. What can be done to address this dire situation? Perhaps the answers lie in the soil itself.
Our goal in agricultural development is to reduce hunger and poverty and increase the self-sufficiency of poor farming households. So from a farmer perspective, to increase your income or produce more food, you would have to have access to various technologies like seeds, for example, or access to markets, but also you need an understanding about soils.
Traditional soil maps are limited by their incompleteness, their static nature, inflexibility, and often unusable scale. The data on Africa, in particular, is sorely lacking.
AFSIS is the Africa Soils Information System, and the idea is to provide sub-Saharan Africa with up-to-date 21st century technology on getting soils information that can be used by farmers, policymakers, and basically everybody.
Recent years have seen an enormous leap in technologies that make a new kind of digital soil map possible. One that promises to be far more comprehensive, especially in areas where it can do the most good. It is more useful to everyone, from policy planners to the farmers themselves.
By definition, we're going from the old maps that are very difficult to interpret to a modern system, web-based, accessible to everybody, that you can query, interact, and it will be pretty easy to interpret the soils information.
AFSIS teams are in the process of surveying and sampling 60 sentinel sites using a spatially stratified random sampling approach. Once a central location is identified, a composite mass sample is taken. The complete soil between 0 and 100 centimetres is measured at 20 centimetre increments. In addition to the main composite mass sample, soil is collected at 3 subplots, which are evenly spaced around the central location. Once the samples have been gathered in the field, they are sent to the lab for analysis. They are logged into a database system before they are sieved and quartered. Some of the samples are then ground finely with a mill and loaded into a plate. Larger samples are loaded into Petri dishes.
What we really want to know about soils is the variation in their ability to supply different nutrients, to store water, to sequester carbon, and to resist erosion. We're now analysing these soils with the simplicity of light. So we're simply shining light on the soil samples, collecting the light reflected back off the sample in different wavelengths. This instrument is a high throughput mid-infrared instrument, and it will pick up these microtiter plates loaded with these fine ground soil samples. It's inserted automatically into this unit with the robot, and then each sample in each hole is scanned from the reflected light is captured as a signal, and you can see here the progress in scanning this plate at the moment. It's going one hole at a time.
The soil is also tested for its engineering properties, as well as carbon, nitrogen and sulfur content. All this data is then used to make up the first digital soil map of Africa.
Once we get the information from the lab, we combine that with the information that we collect in the field as part of our field surveys. And the types of maps that we generate in this project are not really your conventional soil maps, but more maps of functional properties of the soil. So for example, and I've put a map up on my screen just to show an example of that, would be soil organic carbon, which is an important indicator of sort of the fertility status of the soil and the condition of the soil. So the map that you see right here is from 1986. Now we can also then run the same model over more recent images, and we can look at the changes in that 20-year period there from 1986 to 2006, for example. Right? So we can then, that helps us understand sort of where in these landscapes do we have hotspot areas in terms of degradation processes and in terms of soil fertility decline and so on. We can use this now to identify areas where we would want to go in and focus in terms of interventions to improve soil fertility status, for example.
We're seeing some alarming trends. We're seeing rapid soil fertility decline. That has to do with the fact that nutrient replenishment, for instance, is often not taking place. And we're seeing the potential really for systems that are close to tipping points. Tipping points like the ones that we saw today in the gully, to me, that is one form of a tipping point. And there's so much pressure on the land that eventually it's literally the straw that breaks the camel's back. Once the camel's back is broken, it's very difficult to recover that. Even, you know, throwing lots of money and technology at it, that land is basically out of production for two generations. And for most of Africa, this is not something that we can afford anymore. When you get to a situation like this, it's basically impossible to use sites like this for agriculture or even for forestry or any realistic land use. Right? And the idea is to tell people about the quality of the land or any degradation processes that are ongoing at present. The purpose is really to monitor those underlying processes over time and provide governments and others with management information about the land that they're occupying.
The key parts of the AFSIS project are diagnostic trials, which will contribute to soil management recommendations to help extension workers, governments, agricultural institutes, farmers and others tailor agricultural practices. Farmers are participating in trials in the Tanga district of Tanzania. Not only do the farmers learn and understand the rationale for the trials, but the results will be used to inform the management recommendations.
Soil as part of land is a very, very, very important natural resource because it impacts on food production, and food production is at the heart of our sustenance and survival.
Mahindi hapa yalikuwa manene, mazuri zaidi. Mahindi ya shambani kwangu yalikuwa membamba, maana mbegu ilikuwa sio mbegu bora, tuliotesha tu mbegu ya kienyeji.
Hapa kuna mabadiliko fulani nimeona kwa sababu kutokana na zile mbolea tulizotumia kuna mabadiliko sehemu fulani ambazo tuliweka zile mbolea kwamba mazao yake yalipendeza, yalikuwa mazuri zaidi kuliko ya huku tunakolimia. Hapo niko barabarani na kile kiploti, kwa sababu tulikuwa barabarani, ni watu wengi mno wamekuja kwa kuangalia kile kiploti na kukipenda. Kwa hali hii ukipanda hata ile mbegu bora, kama ukupata ile mbolea, bado hali yake inakuwa sio safi kama ile iliyowekwa mbolea.
By making data publicly accessible, AFSIS gives African governments, research organisations, scientists and others the capacity to monitor their own environment and inform better decision making.
I'm saying that the information that we get from the AFSIS project will be used, you know, by different stakeholders, like farmers, policymakers, and several stakeholders.
An information service like this has a real return on investment. It is the foundation of our civilization. And historically, we have seen civilizations collapse because mistreated the land. And we don't want to have this happen in Africa.